Okay, here we are doing a couple of sample problems from the worksheet, this first page here, where we are expanding on the idea of the 34, 13.5, 2.35 empirical rule, and we're using this handy chart. Calculators can do this too, where we can break it down and find much smaller percentage breakdowns for how far you are away from your middle value, your x bar, based on this idea of measuring with standard deviations. And that's what a z-score is. It's just a fraction of a standard deviation. So for example, I'm going to skip these first two problems because they're right straightforward review. They're nice whole number standard deviations. If we know our average is 10.5 and we know the standard deviation is 1.5, then we go up 1.5 to 12, we go down 1.5 to 9. So these are our whole standard deviation, nice round number of values, where our ruler of 1.5 lands directly on these scores. So longer than 12 hours is just the percent greater than that one standard deviation. There's the little bit of 2.35, but then there's a little bit beyond there and a little bit beyond there, so it's better to think like cookie dough. Think the amount below it, which is 34%, and take that away from 50%, because the idea of an average is that above it is 50% and below it is 50%. So that's 16%. The same idea between 10.5 and 12 is between the middle and your first standard deviation. Well, that's just that 34% that you guys memorize. But part 3 here is what percentage of MP3 players have batteries that last longer than 11 hours? Well, 11 hours is going to be right here. It's above 10.5. And it's 0.5 hours. It's half an hour above your average. If the average is 10.5, that's 0.5 hours. And the way we standardize it is we compare it to the standard deviation. It's a third of a standard deviation. It's 0.33. So then we just go to our chart. We look at 0.3. We go over to 0.33 is 12.93%. That tells me that this little band in here that I've colored in is 12.9. So above it is 12.9 taken away from 50%, and that gives us this amount right here, 37.1%. Okay? So now the next problem is, now they've given us a number, 5,000 something MP3 players. What a number of them are between, last longer than 12.75. So that's just up here. There's 12, so 12.75. Longer than that is going to be this amount up here. So I take 12.75 away from the average, and that tells me that that's 2.25 hours above the average. Well, if a standard deviation is 1.5 hours, we divide 2.25 by 1.5, and we get 1.5. That's 1.5 standard deviations. So I go to my chart and I say, okay, where is 1.5? It's right here, 43.2%. So that tells me that from this line here at 12.75, below it is 43. So again, I got to think like cookie dough, and I got to subtract that. Subtract that from 50%. 12. Let's see. What lasts longer than? So I take that 43% and I subtract it from 50. So 50 minus 43.3%. I can't write that there. So it's going to be like 6.7%. And that was a mistake. So 5,375 times 6.7%. Okay? If 43% is down here, then the percentage that lasts above that is going to be 6.7%, which I multiply by the 5,000. That will tell me the total that's above that. Okay, so what percentage of MP3 players have batteries that are between 10 and 12? Okay, well, 12 is one of our nice round numbers. 10 is below our average right here. We know it's 0.5 below. We know this little sliver in here, we've already looked it up, is 12.9%. So I take 12.9% is the part below 10.5, and I add it to the part that's above up to 12, and that's 34%, so I get 46.9%. Okay? Well, what percentage of MP3 players have batteries that are between 9 and 10 hours? Again, 10 is one of our nice, 9 is one of our nice round numbers. And up to 10, well, that's just going to be this lower half. Okay, so I know that that little sliver, we've already looked it up, is 12.9%. So I take away 12.9 from 34, and I get 21.1%. Okay, so on to the kicker here. This is the last part. Suppose the company determines that it can afford to replace 10% of the MP3 players. So 90% that are good, there's 10% that are bad, they're going to refund the money. What is the number of hours that the battery life can have so that it's bad enough that it will be refunded? All right, so the way you think about this is we're looking for this bottom 10% right down here. So lower 10%. So I want to find where's my z-score going to give me 40%, because remember it's always measured from the middle going out. To find the bottom 10%, I need to find the 40% that's right in there. I go to my percentage chart. Remember the z-scores are along this column. To find 40%, I go right here, and 39.97 is the closest to 40%. Well, where is that? I measure this way to 1.2. I go up here to 0.8, so it's 1.28. 1.28 is my z-score. So there that is, 1.28. Then I multiply by the standard deviation. Remember, when I do the absolute measurement, I do an absolute measurement, I divide by 1.5, our standard deviation. Now I multiply by the standard deviation. And that tells me that if I were to be 1.92 hours below the average, that's when I'll know that the battery is so lousy that it gets to be refunded. Okay, so what is 10.5 when I subtract 1.92? Well, that's going to be 8.58, I think, if I've done my math correctly. Okay, so if a battery lasts 8.58 or less, 8 hours, 7 hours, 6 hours, 8.5 hours is below 8.58, that's the refund amount of life. Refund below here. Okay, so hope that helps. Try doing number 2. Good luck.